I'm going to talk about a debugger tool and tracer tool called EDBG. But first, quickly about me, I'm a Swedish Erlang programmer. I currently live in San Francisco and work for Zoom. And I have the usual Swedish background of Erlang history of Ericsson, TLF, Cisco. I'm still missing Klarna and Erlang solutions, I guess. Then I have most of the more common places to work in Sweden with Erlang. My talk today is about EDBG, a TTY-based interface to the Erlang tracer and the int module. Interactive and simple tool to use. There's nothing really new in this tool that you haven't seen in other tools, and it's not it's not better than, for example, I don't know, Redbug or Recon Trace or anything like that. But for me, at least, it's much more simple to use and kind of scale down in how you interact with it. So I never have to look up, for example, documentation on how to use the tool because it's so intuitive to use, especially the tracer. But I did not create this tool at all. It's written by a Swedish guy called Torbjörn, who I worked with at TLF and Cisco. And so this talk is more about me marketing the tool, I'd say, instead of bragging about what I have done. So I just use the tool. I like it a lot, and Tob is a great developer, so I think he deserves to have some exposures for the tools that he has created. Also, shout out to his SoundCloud. Apparently, he makes music. I found out that. So if you want to hear his cool guitar tunes, go there. Even plays banjo, I think. But back to the tool. EDB. There's two components of the tool. It's a tracer and it's a debugger. Both are interactive. The tracer is something that I use a lot. The debugger I don't use that much, but it seems to be very useful. But the tracer I like because it's very simple. It just basically has three simple functions that you need to remember, and then the rest is interactive, and you just use the Erlang shell to use it. So it's a start function where you start throw in a bunch of options to what you want to trace, then you stop the tracing, and then you analyze the trace file that has been created. And I'll go into the details later on what happens in the background when you run these commands. But let's start with a live demo here, and I hope everybody can see my screen. So here I have the Erlang shell, eJabberD is running, and I want to do some tracing. So I just debugger. I just call the start command, and I give a list of the modules I want to trace. In this example, I just want to go for one of the modules, but you can just add more if you want to. You can also narrow it down by saying the module and function. Here, for example, you can have handle info or something like that. But for this demo, I'm just going to use the entire module. And then you can specify a bunch of options for example, narrowing down the scope. In this case, I'm just going to specify a log file I want to use. I'm going to call it, let's just call it first trace. There we go. Nope. Here we go. Nope. Trace. One list. Two lists. Okay, let's just use for some reason it doesn't work. Here we go. I'm skipping naming the trace file and just using the default one that we get from Erlang, from the tool itself. And then I need to generate some traffic. Here we go. So I'm just using Pigeon to write something. Let's do code beam. Just send a message and see that it was received. And then I want to stop the tracing. Stop. And then I want to delve into the trace file to see what happened. So this gives me an interactive loop where I can start analyzing the trace file that was created in the background. And you see a list here of the process and all the different functions that was called in order. And then you can start inspecting them. So for example, using the index on the left side here, I can inspect. I just type the number, I inspect one of the function calls, for example, the first one, which gives me the function header and the arguments it takes. And then I can start looking into these arguments by saying I want to show the first argument, for example, whatever this EL thing is. And it will give me something we call an Erlang EDBG stanza, showing me the content of the argument. Since I know that this is a record, I can also print it by using PR, which gives me a nicer format of the record output. I can also see what this method return, this function returns. So I can say that I can use R for return and say I want to see what this method returned, and this is the return value. Nothing too complicated, but very simple and straightforward. If we go back to look at the list of methods, I can also step down into this list and step up to see all the different functions in the trace. And I can also search for something specific. For example, I want to find the function C2S handle send, for example, which I'm currently interested in. And I also want to, and this was probably called multiple times because this is a live tracing. So a lot of stuff's happened in the system. So I want to only search for something that happens in the first argument, like a free string that contains code beam, which was what I put into the message. And by doing this, hopefully it will find me this function call. So I see that number 73 seems to be the handle send that contains code beam. So if I inspect this function by, again, doing the show command, mentioning the number, and then looking at the first argument, I see that somewhere within the first argument, we have the string code beam. So it's just a free text of the arguments. You can also search for return values if you want. And you can search for, that's basically it. You can search for function, whatever's in one of the functions parameters, and you can search for return values. You quit the loop by pressing Q, and I can start another trace by adding some more options. For example, I want to get information about memory consumption, for example. So I say that I specify that I also want to see memory consumption, and I also want to see time consumption, monotonic TS. And this will start a new trace. I will generate some traffic here. I'll write foo, and I'll write bar, for example. And I'll stop the tracing. Stop. And I'll inspect the trace file again, and hopefully we'll have some more information now. We see the memory consumption, and we see the time consumption in nanoseconds for each of the calls. So we'll go to the top here, for example. If we think that this information is too messy or something like that, we can also turn off, for example, the memory output and turn it on again. So now we only see the nanoseconds, and then I can, of course, turn it on again if I want to see that. And that's basically what this tool does. It's a super simple way of showing you what goes on in the system with traces. Let me go back to the slides and show you some details on what happens in the background when this is running. Okay, first, let's talk about some options that you can throw into this tool. The log file that I, for some reason, failed to add. If you want to use a specific log file or different log files for different traces, otherwise you get the default EDBG trace result. You can narrow down the scope of the number of trace messages that you want to have for your log file. and how long you want the tracing to go on. You can also, later versions of OTP, you can also give some trace spec to the trace to also minimize what the system traces. I think the default just everything, I guess, but you can give options like processes, for example, that you want to narrow it down. You can tell the tracing how often it should write to the file. Either you do it eagerly, then it writes often, which is good, I guess, if it's a system that might go down while you're doing the tracing, or you do lazy, which basically means that it will put down the output to the file, either when you reach the maximum number of messages, or the timing, or when you run the stop command. I showed you the monotonic and memory options. There's also one for send and receive where you can trace messages from both the process that sent them and the process that received them. And you can only do that for known PIDs. And by known PIDs in this context means that it's a PID that has already been part of the tracing. So we don't get swamped with messages coming from other parts of the system or somewhere that we're not really interested in at this point. Just to give an example of how it looks like when you have the send receive option turned on, you will see in the list, you will see a bunch of send and receive references, and you can inspect them just like you did for the function calls. And for example, showing how the number 6 send message looks like, you get the result, and looking at the receive message, you can see the result there as well. So it's also a good way to inspect whatever message has been sent to and back and forth to your process. Behind the scenes, it uses the trace pattern built in the BIFs directly. So nothing really magical. There are older versions to the APIs which uses the DBG Erlang module, but the three methods or the three functions that I showed you uses trace and trace pattern directly. Stores the output in a file, so it's of course useful if you use a tool in Common Test or some kind of test tool and you want to inspect the files later on. It can produce a lot of tracing, so it's important to only trace what you want to trace and then limit the tracing with either the timeout or the message size or both. So that's all I had on the tracer part. Next, we go into the debugger part, and here, so I don't fail the demo, I'm just going to show you a bunch of slides. The debugger has a bunch of methods or functions, and I'm not going to go through them all. I'm just going to show you the overall ones that you most commonly would use, I'd say. And if you've used the debugger, you will recognize this. And this is built on top of the int module, so it's also nothing magical going on here. It's just a nice interface to access the debugging information that's already present in Erlang OTP. So to start a debugger, you use the EDBG I function. You specify the module and the line that you want to have a line break on. Once you've done that and you run some tests or you run the code, you do plist to list all the processes. And you notice that on process 648 here, there's a break, and you see which line and you see which module. And then you attach to that process, which gives you a view of where we currently are where we are in the code. That we're standing on the breakpoint at the moment, which is apparently on line 1189 in a DB. And then you have all these options that you probably recognize if you've used a debugger in any way, where you can step down into a method, a function, or step out of a function, and step to the next line and finish the functions and things like that. So by pressing N, you just go to the next line. You can see that you have a little star that still marks where the breakpoint is. And you can inspect the content of a variable once you've passed it by using V and naming the variable. You don't have to name the entire variable, but unless there's some ambiguous things going on. Otherwise, you can just do the prefix and it will show you whatever that variable has currently. You can step into a function. So if we're standing on line 1203 here, fix abs URI, we can use S to step into it. We can use U to step up out of it again. And if we encounter a module that we haven't interpreted yet, for example, the JAWS stats module here, we just press I and the name of the module, and that module will be part of the list of interpreted modules, which of course, after we've done that, we can continue our debugging and stepping into the function of that module instead. Another cool thing that you can do that I don't think that you can do in the graphical debugger that comes with Erlang is that you could have conditional breakpoints, for example. So you could pass into a function into this IT function, which needs to return either true or false when you create your breakpoint. And in this case, it will return true if SSL variable contains the value no SSL, otherwise the breakpoint would be ignored. And then you run your test and you attach the correct process. And in this case, we actually have the value of no SSL, so that's why we're stopping at this breakpoint. Otherwise, it would just have continued. So this is kind of nifty, I guess, although I have never used it myself. Behind the scene, it just uses the int module that comes with OTP. But it provides a nice TTY-based interface, interactive interface in that nice loop that you saw. And it also has the possibility to add conditional breakpoints, which you of course can do with the int module, but I don't think you can do with the graphical debugger, for example. This is located open source on GitHub on this path. Tove will be more than grateful if you start using it and if you start contributing to it. I think that there are some things that would be nice to have, like searching for things backwards in the trace file instead of just forward and stuff like that, that I would like at least. And that's it. I think I'm pretty much within the time limit, so I can take questions if you have any.
There is one question in the Q&A section by Jakub Witzkat. Sorry, I mispronounced that. So Jakub, would you want to put your mic and speak the question?
Can you hear me?
Perfectly.
So assume we have an argument which is a huge one, tuple or a map. Is there a way to somehow select only part of it and not display the whole tuple or a map and spam the terminal?
No, you get the entire thing, but that would be a cool feature to add.
Thanks.
Does anyone in the audience has any questions?
Yeah. Can I use this with, how can I use this with Elixir?
I'm not an Elixir user, but I assume you can just load the beam into the VM and use them like however you call native Erlang commands in Elixir. But I am no Elixir expert at all, so I'm not entirely sure how that works. But I assume you can just use it as native commands. Yeah. Feel free to add a cool Elixir interface to it as well.